Watch a worker slide a raw pizza into the oven. You step up to a counter, place an order, and walk out with a meal. You have zero involvement in the temperature of the oven, the proofing of the dough, or the assembly of the ingredients. You delegate the entire creation process. In system architecture terms, you are the client. The pizza you want is the product, and the shop itself acts as the factory, encapsulating all the complex logic required to actually bake it. You execute this transaction without a second thought. But this delegation structure is a formalized software architecture. It is the Gang of Four factory method pattern. Once you understand how this everyday transaction isolates the requester from the creator, you will see this exact structural seam hiding everywhere in enterprise codebases. Take a look at this naive block of code. The client logic directly instantiates specific objects using the new keyword. It explicitly names the concrete classes it wants to build. The danger here surfaces the moment your business requirements expand. If you need to add a third or fourth variant, you are forced to crack open this existing, perfectly working block of client logic to add more conditional branches. This strike-through marks a direct violation of the open-closed principle. Software entities should be open for extension, but closed for modification. By tightly coupling the client to the concrete classes, the resulting code becomes fragile. Every new feature risks breaking existing functionality, and isolating the client for unit testing becomes difficult. The factory method provides a disciplined architectural escape hatch. It defines a method for creating an object, but delegates the actual instantiation to subclasses. Stripping away the jargon leaves us with a single core strategy. We must separate the code that remains stable from the code that frequently varies, and force them to communicate through a clean abstraction. A stable product interface sits atop concrete products. Below, a generic creator houses our factory method. Specific concrete creators implement it, instantiating product variants. Clients interact only with interfaces. Memorize: one product, many variants. Subclasses decide the concrete class. Let's map our real-world analogy directly onto this formal architecture. The customer wires perfectly to the client. The pizza maps to the product interface, and the shop aligns precisely with the factory. Mapping these actors to architectural roles shows that the pattern is a formalization of a process you already use. It moves the concept from an academic definition to a concrete mental model. We are going to build this pattern from nothing, type by type. The strict discipline here is that every piece of code we write will only ever depend on the abstraction immediately above it. Step 1. Here is our primary abstraction: the notification interface. Think of this as the generic concept of a pizza. This interface acts as a concrete wall in our system. Client code will rely on this contract, never knowing what specific logic lies beneath it. Step 2. We create our concrete products. We implement the interface with an email notification and an SMS notification. This structure enables interchangeability. Because they share the same interface, you can add a dozen new notification protocols tomorrow without editing the code that calls them. By completing these first two steps, we have successfully barricaded the volatile parts of our system behind a stable contract. Step 3. Moving to the creation side, we define the abstract notification factory. This class contains a single overwritable hook, the factory method itself. This specific class centralizes all construction. By forcing creation through this single abstraction, we effectively banish the new keyword from the client's vocabulary. Step 4. We define the concrete creators. The email factory and SMS factory extend the base class, each overriding the hook to return their specific implementation. Step 5. Look at this two-line client wiring. The client instantiates a factory and calls the notification logic. It interacts solely with the interfaces, blind to the concrete classes doing the work. Seeing all 5 blocks fully assembled reveals the complete, total architectural payload. Follow the glowing dependency lines. The client request flows through the abstract factory down to the concrete creator, which instantiates the specific product. Flexibility is achieved through inheritance, and the specific variant is fixed at compile time. Because we built this structure, if a new requirement demands push notifications tomorrow, you simply slot in a new subclass. You never modify the existing tested client code. The reality of software development is that no architectural pattern is free. This design buys you flexibility, but it introduces indirection to your codebase. This list of pros shows exactly what you gain. It eliminates hard-coded instantiation, strictly enforces open-closed principal compliance, and isolates all creation logic into a single responsibility. But notice the trade-offs on the right. You risked an explosion of parallel subclasses, one factory for every single product variant. Applying this pattern is overkill for trivial object creation. The strict trigger heuristic is this: reach for factory method only when you have one product but many variants, and the future flexibility actually pays for the added complexity today. This graphic highlights a common trap in system design interviews. Do not confuse factory method with abstract factory. The difference is scope. Abstract factory creates an entire family of related products. Factory method creates just one. Knowing exactly when to deploy a pattern and precisely what not to confuse it with is the judgment signal senior engineers look for. Factory method in one breath. One product, many variants. The subclass decides which concrete class is instantiated. This cheat card puts the entire architecture in one place. The subclass chooses the product. Now that the analogy has clicked and you've seen the code assembled, you will notice this pattern operating in the wild. Drop your own real-world codebase examples in the comments below, and subscribe to compile the rest of the Gang of 4 design pattern catalog.